All right, and we're talking about equations of lines. Are the I guess we need. I thought we turned this on. There we go. The most important thing, the kind of the key characteristic of lines is the slope. This will come on in just a second. And usually we use the letter M for slope. What is the kind of the everyday way we think of slope? How can we describe the slope? Yeah. A hill. So it has to do with how steep the hill is. So with lines, how do we describe the everyday way we describe the slope of a line? How can we describe how steep it is? I'm sure everybody knows it. You're just maybe not sure exactly what we're looking for. Rise over run? Yeah. That's kind of how we think of the slope. Rise over run. So how much are we going up and down compared to how much we're going side to side? If we're going up and down a lot, then our slope is pretty steep. If we're going up not very much as we go side to side, then our slope is not very steep. The way that we're going to describe this with coordinates is y2 minus y1 over x2 minus x1. And this is between the points x1, y1 and x2, y2. We've talked about this. This has come up several times in the algebra reviews, finding the slopes between points. All right, horizontal lines. What's the slope of a horizontal line? 0. We're not rising at all. A vertical line. So we're only rising, we're not running. So what's our slope going to be? Well, our run here is 0. What happens when we divide by 0? Undefined. Horizontal line has slope 0. Vertical line, slope is undefined. Because our run is 0, we're dividing by 0 in our formula for the slope. All right, so we good with slope. Again, hopefully this is more or less review. So really what we're interested in is we're interested in the equations of graphs. Today we're going to, the equations of lines. Today we're going to graph lines. So we have two forms of equations. So two forms that we're going to use mostly. One is the most familiar form for the equation of a line. The slope intercept. And that's y equals mx plus b. And this is our slope. And this is our y intercept. What do we mean when we say y-intercept? What is that telling us about the line? Yeah?
Where it crosses the y-axis.
Where it crosses the y-axis. That's what the y-intercept means, where it crosses the y-axis. So the slope-intercept form will always give us a point that we can start our graph with, the y-intercept. The other form of the equation of a line, the one that ends up actually being more useful, and you'll see it used more as you move forward, is the point slope form. And this is for a line with a slope equal to m, and it goes through the point x1, y1. So our point slope form of the equation of a line, y minus y1 equals m x minus x1. So again, this is our slope and the point. x1, y1. So the point slope form also gives us a point that the line goes through, just in a slightly different way. And we can rearrange the point slope form of the equation of a line to get the slope intercept form. But the point slope form is useful because a lot of times with problems you know a point and you know the slope. So you don't even have to worry about the y-intercept. You just use a point slope form. All right, so I just want to sketch a couple of graphs, for just a reminder of how we go about graphing lines. And then we'll be done. So I just want to go through a couple of examples. So we want to graph y equals 1/2 x minus 1. So for this line, the slope is 1/2. And the y-intercept is -1. So we can use those two things to get a nice graph of this line. I'm going to make a little grid here. The y-intercept is -1. That's one of the points that we can put on our line. The graph crosses the line at y equals -1. So right there on the y-axis. And then we can use the slope to plot some more points. This says to go up 1 over 2. So from here, I'm going to go up 1 over 2. And usually you want to plot 3 points to make sure you're accurate. Up 1 and over 2. And then I'm just going to connect those with a nice line. And there would be a graph of that line. And the slope is positive 1/2. That tells us we should be going uphill as we go from left to right. Any questions on how we graph that line? All right, let's look at one in point slope form. We're still graphing y minus 2 equals -2/3 x plus 4. Now, this is in point slope form, but in point slope form we have y minus and x minus. So I'm going to rewrite this. Y minus 2 equals -2/3 x minus -4. So we have x minus, so it matches up with our point. So this has a slope -2/3, and it goes through the point -4, 2. So the x part of the point comes from here, and the y part comes from here. So then I'm going to sketch my graph. All right, so here's my point, -4, 2. And the slope is -2, 3. So we're going to go down 2 and over 3. And then down 2 and over 3. The negative says go down 2 and over. And connect those points with a nice line. My grid is not perfect, so I'll just make my points a little bigger. And there would be the graph of that line. And the slope is negative, so it should go downhill as we go from left to right. All right, questions on sketching those graphs? Use your point that you know, either from the y-intercept or from the point-slope form. And then use your slope to plot additional points. All right, the last thing. Vertical and horizontal lines. The equation of a vertical line. No matter what y is, x doesn't change. We don't go side to side at all. So the equation of a vertical line is x equals a constant. So, for example, x equals 5 or x equals -2. X stays at 5. No matter what y does, x stays at 5. So we go up and down from 5 for a vertical line, or up and down from -2. We don't ever go side to side. For a horizontal line, our line is horizontal, so x changes, but we never go up or down, so y never changes. So our equation of a horizontal line is y equals a constant. So y equals 3 or y equals -4, for example. Y equals 3, x is whatever, no matter what, y equals 3. We never go up and down from 3. So those are the equations of a vertical and horizontal line. All right, questions? Okay. So what I want to do